All right, aren't you super excited to hear my voice again? I know you are. Probably even more so now that it's through a computer screen. I can see Joel just being really happy and Noah being very happy about this, but that's okay. Just mess with you guys. Um, so this is my first video for you. Been recording all week. Um, so you guys are one of my last videos. Last is best, right? Um, so let's kind of like break down how this is going to work. So I'm going to record myself. I'm going to take the sections, and typically I'm going to break them down into 2 or 3 parts. So maybe the videos are no more than, I don't know, 6 to 10 minutes ish. I'm trying to make it not so overwhelming and that you can do it in parts, especially if you're just really not feeling it that day. But no, there are due dates with everything, and everything's kind of laid out on Google Classroom, so you have all that information there. Um, I'm gonna move faster than normal. Um, from what I've noticed with all of this, I have been. And you have to think that I am literally talking to a computer screen right now in my classroom. Sometimes it's in my apartment. And there's no one slowing me down or asking me questions. So if you feel overwhelmed or if it's moving too fast, pause the video, catch yourself up, process the information, and then start playing the video again. Okay, that's my best piece of advice. If you need help, comment, email, message on Remind, whatever you need to do, and get a hold of me, and I'll try to kick out a video real quick with some explanations. So this is 9.1. Let's go ahead and do the warm-up just to do some math. So slope-intercept form is y equals mx plus b. We simplify this first and get 8x. Everything stays the same. And we want the y to be by itself. So we're going to subtract the 8x and the 12, leaving us with negative 8x minus 6. And then we're going to divide this negative 2, and you get 4x plus 3. All right, so that's slope-intercept form. Nothing really to do with what we're doing today, but just to warm up. So, law of sines. Law of sines are generally meant for non-right angle triangles. I didn't mean to write angles. Angle triangles. All right. You can use them for right triangles. You absolutely can. But in my opinion, it is so much easier to use regular trigonometry, like the opposite over hypotenuse, adjacent over hypotenuse, those trig ratios, than the law of sines. But you have every right to do it that way for the law of sines if you really want to. But typically it's for just general triangles. So here's my one issue that I realized, and I actually already recorded this video until I made a mistake, and I just felt like starting over because it wasn't too far. If you notice, it says sine of capital A over A. The angle is typically the capital letter, and the side is the lowercase. But my picture is the opposite. So it really should be like this. Let me fix it. And I'm sorry for that. I need to change the image. It's just not my concern right now. Trying to get all these videos going. So there's different cases of information you can get, and these should look familiar from geometry when you did like similar triangles. So SAA is side angle. Obviously I spelled this one backwards on purpose, so I did not get myself in trouble because this is going on the internet. That'd be the last place I'd want to spell that word on accident. That's a special case. We're going to talk about that in the next video. So this is side angle side. So we're just going to review this type of information and what this means. And obviously it's side, side, side. All right. So that's just saying what kind of information you get. to be able to solve the triangle. Now, anytime you have an example where it says solve the triangle, you have to find every angle and every side. So when it says solve the triangle, you're literally getting all the information. So I'm going to make an underline of the ones we need to fill out. I'm going to tell you right now that my horizontal lines are atrocious for some reason on this thing. I'm using like a 6x4 inch tablet, and it's just weird to write horizontally. I don't know why. So we don't have angle A, we don't have side A, and we don't have side B. So I'm just putting lines there so I know that I need to find that information. We have angle B, because it's across from that B, and this isn't written, but we can figure that out logically, that this is C. So B is 50, C is 110, and we know a triangle is 180 degrees. So you can take 180 minus 160 or 110 minus 50, and you get 20 degrees. Okay, so we actually have all the angles, which is nice. And in this situation, we have angle, angle, side, or side, angle, angle. That's the information we're given. Just little pointers to check yourself, okay? The bigger the angle, the bigger the side. The smaller the angle, the smaller the side. So if we think about this logically, this is side or angle of 20. Side A should be the smallest, okay? And this picture kind of shows it, but you don't ever want to assume it. This angle is right in the middle. Well, not directly, but you're going to say it's the middle angle. So it should have a value that is more than A, but less than C. And 110 is an obtuse angle, and it's the largest angle, so this should be this biggest side. So A and B, if you get anything over 12, you did something wrong. Okay, something is massively wrong. And I'm just going to put units just because I can. All right, so you want to use law of sine when you have an angle and side, a duo. I'm going to call it that, a duo. You have the angle and the side of the same thing. So you have the angle and the side directly across from its value. If you have that, law of sines is the way to go. Now I know it's written as like A over A, B over B, C over C. You don't have to use all three at once. You have to know that this sign equals this sign, but it also equals C. These all are equal to each other. So it doesn't really matter if I write it out as 3. I only need a ratio equal to a ratio. So that ratio with complete information is dealing with the C's, right? Then I'm going to try to find one of the sides. And it doesn't matter which one I go with first. Okay, I'm just going to go with A. We figured out what angle A was. Now we need to figure out what sine A is, or the side of A is. Now, these are in degrees. That means your graphing calculator needs to be in degree mode. So make sure it's in degree mode, or you will get some really wrong answers, okay? From here, you're just going to cross multiply. So A and its sine of 110 equals 12 sine of 20 degrees. Now, if you calculate this, hit equals, then divide it by the sine of 110, your rounding is going to be a little off. So I highly suggest doing it all at once. Okay, so you would divide the sine of 110 over. Apparently we're having some kind of delivery because they are loud and my window is open. But when you do this, when you divide that 110 over, you're going to need to put parentheses in your calculator, potentially, because it might mess up your order of operations. I don't think you need it, but I always like to be safe than sorry. So if you type in parentheses 12 sine of 20 in degree mode, divided by, make sure you end the parentheses correctly, divided by sine of 110, you get, and let's go to, I don't remember what your daily practice says, let's go to 4 decimal places. You get 4.3676. So 4.3676. Now let's talk about this. Side B, we have to figure that out too, okay? Some of you might ask, could we use the Pythagorean theorem? And I hope you hear that I'm hitting the desk because my answer is going to be no. The question is why? Why can't you use the Pythagorean theorem? Well, the Pythagorean theorem is only used for right triangle. So, Pythagorean theorem equals right, that's really bad, triangle. Do not use the Pythagorean theorem to find b. Do not do it. Please do not do it, okay? You have to use the law of sines here. So I'm going to use what information I started with the side C. We have to keep in mind that this is rounded. So if I take a rounded answer into my answer that I'm going to have to round, it's like doubly rounded. So it might get off a little bit. So I always like to use what information they gave me, unless it's the rounded information, my rounded answers are actually like 100% necessary. So now we're going to find side B. So it's sine of 50 over B. Doing the same thing, B times sine, I'm going to run out of room, 110 equals 12 sine of 50. We're dividing that over, which leaves us with this. And we go ahead and calculate our answer. Again, bear with me. I'm writing on a small tablet. It's really weird depending on where I'm writing. My handwriting might look atrocious. So I get 9.7825. So we have our answers. Let's make sure they make sense. Smallest angle, smallest side. Medium angle, let's call it that way. Medium side between the two. And largest and largest. So we are good to go. So this should be review. It shouldn't be anything too new, but it's not really anything too complicated. Okay? I definitely think you're capable of doing this. So how about this? I'm going to set up number 2, talk about it a little bit, and then I want you to try to do it. So I'm going to talk here for a little bit. I'm going to have you pause the video, and once you either get stuck or once you get it done, restart the video, and I'm going to go through the explanation. Typically with this, I go a little bit faster because I'm hoping that you have the answer. I'm hoping, and I really think you guys are capable of doing this. It's trig, but it's not really the trig we've been doing. It's kind of an easier version, I think. There's only one little hiccup in this, and we'll talk about that in the next video. Okay, so we have angle B, which is 124. We don't know angle A. We don't know angle C, so it's different than the last one. We do not know side B. We do not know we know side A, sorry. And we have side C. All right, so this is the breakdown of information. You have to figure out what you can do, okay? So go ahead and see what you can do with this one, all right? So pause the video now. All right, so now you restarted the video, and I hope you noticed an issue. Okay, so I either made a typo or I did this on purpose when I made these notes, and I don't really know which one it is. So I told you didn't have to write a ratio like this, but I'm going to write the entire rule out. Okay, so we run into a bit of an issue with this. We do not have a complete ratio. We do not have that angle side duo that we need. Okay, so this problem is not possible. So not with what we're trying to do, not with the law of sines. It's possible, but not with where we're at. So let's go and talk about what we have. This is a side angle side. And I want to see if this is on our thing. So side angle side did not work for us. Okay, so put like a double star. So side angle side did not work with what we had. And there's a reason. You actually have to use the law of cosines. And that's our next section. Well, that's a star. I'm going to write star because that's horrible. That's our next section. And I must have just put an image in without realizing what I did. That's going to be my guess. So this is not possible as of this section. Next section, absolutely, it's possible. Bad example on my part. Okay. So let's go ahead and do this next one together and see what happens. Okay. And this is going to be the last um, part of this section. I'm going to break it down into two parts because we're going to get into something that's called the ambiguous case. And that is the only thing that is, I think, difficult with this. Bear with me. I'm going to try to use the line tool because I know my triangle is going to be atrocious. I always make the same triangle when dealing with this. So nothing's to scale. I don't even know if there's an obtuse angle, but this is just the triangle I always seem to make. So they're giving us information about triangle A, B, C. And it doesn't matter where A, B, and C are because we don't really know what's going on. But we know this is 42 degrees. Side A, which is directly across, is 70. B side is 122, and that's all we know. So I'm going to run out of room. I know it. So I'm going to write the angles and then the sides this way. Kind of put that triangle in a space where I couldn't have it. So, or don't have room to write this. So I have 42 degrees for A. Side A is 70 and B is 122. And I don't know this information and I can't find these sides. You can't take 180 minus 42 divided by 2. It doesn't work that way. We don't know if it's an isosceles triangle. So we can't find these out unless we have 2 of the 3 angles, okay? But we do have a side and angle duo. So we have sine of 42 degrees over sine of 70. And by sine of 70, I do not mean sine of 70. Whoops. Of 70. Okay. I've done so many of these videos. It's just crazy. My brain is either on overdrive or overwhelmed. We need to find side C, we need to find angle C, and we need to find angle B. But you need to have you can only have one piece of information missing from a ratio. So you have to use some kind of information you have for the other side angle duo, and that would be the side B and angle B. So we don't know the angle of B, but we do know the side. Okay, so we're going to cross multiply. You will always cross multiply when you have a fraction equal to a fraction. And this is what we get. Now, we haven't done a lot with solving for the angle, but you've done it in the past, okay? So it's a little different approach. Keep that in mind. You definitely need a calculator for this. You're going to divide 70 over. And if you divide 122 sine of 42 divided by 70, you get 1.1662 equals sine of B. So the question is, how do you find this angle? Well, there's something on your calculator right above the sine, right above the cosine, and right above the tangent. And I'm going to write it over here. Since I'm really bad at clicking this button on my calculator, or on my calculator, good lord, on my pen. And so I'm sorry about that. There's something written like this right above the sine button. Well, that is inverse sine. And basically, it negates a sine. So sine, and there has to be something here, like an angle. So just bear with me. These two cancel each other out, okay? And whatever angle is here, actually, we're going to write it this way. If it's like this, these two cancel it out, and then you get x. And that's the reverse if this was sine to the negative first here, and this was sine here. But whatever you do to one side of a equation, you have to do the other. So we're going to take the inverse sine of both sides. And yes, we're going to run into an issue. Not my best notes, but it's okay. When you do that, you get, let me go back to the color was that. You get, oh, why is it doing that? Hold on. We got to make sure we go back to that fun color. There we go. Okay. You get B, which is what you're trying to find, and you're going to type this into your calculator. So we do inverse sine of 1.1662 1662. And you get a domain error, okay? Domain error. And there's something we have to think about. When we graph sine, it looks something like this. The highest value is 1 and the lowest value is -1. So we're not within, really should say the range error, but it's okay. So we can't get this answer, but that is exactly how you go about it, just to let you know. So I'm not giving great notes. I'm not, but this is something you need to know, so it's okay. There's an error there. So this one is not possible. Basically, there's a ratio issue with what information they gave you. And this one was done on purpose. The one above, not a good example. Here, this was done on purpose, okay? So you would go through and solve for B if this worked. Okay, so if B worked, you'd get an answer. And then you would find angle C, and you would do the exact same thing because then you have an angle, but then you have to find the side. So it's not overly complicated, I swear. It's just, I'm giving you some not great examples. So this is part 1. Part 2 is going to show up in your left-hand corner in a little bit. Go ahead and move on to that unless you want to kind of break it up as you go. The next part is an ambiguous case, and it's a little weird, all right? So thank you. See ya.